Hi students, today we are going to start a new chapter, probability, right? Introduction of probability. Today completely we are going to give a full introduction to the probability, right? So what is mean by probability? What is mean by probability? Probability is something by number of chances for getting a success or failure. Whatever we are doing some work, there is a chance for getting success or failure. Number of chances, that is something but probability, right? So we are having formula and we are having some notes that only we are going to see that. So probability of an event, how we will denote the probability of an event is something about P of E, right? P of E. So P of E is equal to number of outcomes favorable to E, right? Number of outcomes favorable to E whole divided by number of possible outcomes of an experiment. Number of possible outcomes of an experiment, that is P of E is equal to N of E divided by N of S. N of E is nothing but number of outcomes favorable to E, right? Number of outcomes favorable to E divided by number of possible outcomes, that is total number of possible outcomes of an experiment. Right. This is the formula. This is very important. So P of E is equal to N of E by N of S. So the total probability of an event, the total probability of an event is 1. The total probability, the sum of success plus sum of failure. Sum of success plus failure is equal to 1. So probability of success plus probability of failure is equal to 1. That is the total probability of an event is something but always it is equal to 1. For example, 15 people's participating in a game, right? 15 people's participating in a game. 5 of them are getting prizes. The remaining 10 are not getting prizes, right? So probability of getting prizes plus probability of getting not getting prizes is always it is equal to 1. That is something probability of success plus probability of failure, right? Probability of success plus probability of failure is equal to 1. How we will denote as P of E plus P of E bar is equal to 1. It is something but looks like a equation, right? Suppose if P of E is equal to 1 minus P of E bar. We are having an equation, right? If you know the value of P of E and ask you to find P of E bar, that is P of probability of failure, right? Probability of failure, if they are asking means how we want to find. We are having a equation, whatever we are having, substitute in that and just bring it to the RHS, we will get the remaining, right? Suppose if we know the probability of an event and ask you to find probability of a not complement, right? Probability of E bar is asking, so we have to keep the P of E bar in the LHS and taking P of E bar E to the RHS. So 1 minus P of E, right? We are having some important note. The probability of an event which is impossible to acquire, is 0. Such an event is called impossible event, right? So the probability of an event which is impossible, that is right, impossible. A very good example, a person studying a lawyer and he is attending a medical interview, right? For getting a doctor job, medical job, right? It is possible? No, it is impossible because he is a lawyer. He is eligible only for getting a lawyer job, right? Like this, so many things. See, I am just giving an example. Sun rising in west. Is it possible? Sun is always rise in east only. 8 days in a week. Is it possible? So these are nothing but probability of an impossible event. So it's nothing but 0, right? The probability of an event which is sure, conformly we are having, that is something but which is sure to occur is 1. Such an event is called a sure event or certain event, right? And the next one is something but a very important one, right? We can expect for the 1 marks also, right? The probability of an event, it is greater than or equal to 0 and less than or equal to 1. That is P of E is greater than or equal to 0, less than or equal to 1. There is nothing but the final answer, right? The final answer will be greater than 0, greater than or equal to 0 and less than or equal to 1. It won't go more than 1 and it won't go less than 0 also, right? That is very, very important. So probability of an event will always lies in between 0 to 1, right? 0 to 1. Important points to remember, right? We are having some important points, right? So event and total number of possible outcome. These are all constant one. If you are having only one coin, for one coin the total number of possible outcome is something but 2, right? N of S, total number of possible outcome is something but, how we will denote it is something but N of S, right? N of S, it's a constant one, so you have to thorough it, but how it is coming we will see, right? That is very important. From that only we have to count the favorable outcome, right? This is nothing but total number of possible outcome. That is nothing but sample space we will see. So one coin is nothing but for one coin, how many total number of possible outcome? 2. First I will read out and we will see some example, right? For 2 coins, total number of possible outcome is nothing but 4. For 3 coins, total number of possible outcome is nothing but 8. For 1 die, how many total number of possible outcome? 6. So N of S is equal to 6. For 2 dice, the total number of possible outcome is nothing but 36. For 1 week, how many number of days? 7 days. So N of S, total number of possible outcome for 1 week is nothing but 7 days. For 1 year, number of days is nothing but 365. Weeks means 52 weeks plus 1 day, right? For 1 leap year, 366 days, 52 weeks plus 2 days, right? And prime numbers, 1 to 50 is nothing but 15. It's a constant mark. Number of possible outcome, total number of possible outcome for a prime number 1 to 50 is nothing but 15 only. What are they? We will see afterwards, right? Prime numbers 1 to 100 is equal to 25 numbers. Suppose prime number 50 to 100, right? 50 to 100 means how much is possible? 25 minus 15, 10. Yes. Total number of possible outcome is nothing but 10. Understood? So these are the very common thing, right? We are having so many. These are the common total number of possible outcomes for the some events, right? So we will see that. We will see a sample space. Then we can go to the next one, right? Sample space for 1 coin, 2 coin, 3 coins, right? 1 die and 2 die we are going to see, right? Sample space, right? Sample space. That's nothing but what are the possible outcomes are there? What are the possible outcomes are there for a particular event? For 1 coin, right? What are the phases are there? For tossing a coin, what are the possible outcome to get? It's nothing but head or tail, right? Head or tail. So 1 head and 1 tail. So number of possible outcome is nothing but N of S for 1 coin is nothing but 2, right? Suppose I am having a 2 coin. So what are the sample space? What are the sample space for the 2 coins, right? What are sample space for the 2 coins? So I am having a 2 coin. I am tossing a 2 coin at the same time. What are the possible outcomes are possible? Both will get us a tail or both will get us a head. Otherwise, the first coin will be a tail and second coin will be a head. Otherwise, the first coin will be a head and second coin will be a tail, right? These 4 only will get a chance, possible outcomes, right? These 4 are the possible outcomes, right? When we are tossing a 2 coins, what are the possible outcome? Both coin will get a tail or both the coin will get a head or the first coin, that's very important. So we have to differentiate. The first coin will be a tail, second will be a head, or first coin will be a head, second will be a tail. These 4 only possible outcomes, right? So number of these are nothing but sample space. So number of possible outcome, right? N of S for the 2 coins is nothing but 4. 1. This is 1, 2, 3, 4. Right? Number of possible outcome N of S 4. Suppose we are having 3 coins. What is the sample space? Right? When we are having a 3 coins, what is the sample space? Very simple. When I am tossing the 3 coin at the same time, all the 3 coin will become a tail. All the 3 coin will become a tail, or all the 3 coin will become a head, right? All the 3 coin will become a head, 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 right? These two are the first, these two possible outcome. Still we are having, suppose the first coin alone will be tail, right? First two coin alone will be tail and last coin will be a head. So tail, tail, head is possible. Next, the first coin and third coin is tail and second coin is head, right? The next one is something about head, tail, tail. I am using the head in the third place. Next I am using the head in the second place. Next I am using the head in the first place, right? Next, in the three heads, right, I am using only one tail alone. First two coins are head and the last coin is something about tail. Next, head, tail, head. Next, tail, head, right? Totally these 8 are the possible outcomes, right? How many number of possible outcomes? 1, 2, 3, 4, 5, 6, 7, 8. So n of s for the 3 coins, that is total number of possible outcome for this 3 coin is something but 8, right? How I am framing this sample space, understood? So tail, 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 head, head, head. In the 3 tail I am using only one head. First in the third place, second place, next first place. In 3 heads I am using only one tail. First third place, next second place and first place, right? Understood? Next one die. You know that die, while we are playing, we will use to play, right? How many number of faces for a die? 6, right? How many number of faces for the die? 6. A best example, I'm just taking an example as a eraser, right? How many faces are there for, this is something looking like a dice, right? While we are playing something but dice, how many faces are there? Top and bottom, right? 1, 2, right? Next, top and bottom, left, right, front, back. Totally how many faces? 1, 2, right? 1, 2, 3, 4, 5, 6. Totally how many faces? 6 faces, right? So sample space for one die is something by 1, 2, 3, 4, 5, 6. So total number of possible outcome is nothing but n of s is nothing but 6, right? For two dices, for one die and 2 dices, right? For 2 dices, when we are having a 2 dice, right? When we are having 2 dice, how many are possible means, see, we are having 2 dice, right? We are having 2 dice. See, this is first die and this is second die. First die is nothing but only one, and second die alone will get a 6 outcomes, right? So 1, 1 is the first possible outcome. Next, second one is nothing but 1, 2. The first die is nothing but 1 only. With 1, how many number of possible outcomes are there for second die? 6. 1, 2. Next 1, 3. Next 1, 4. 1, 5 and 1, 6. Next, the first die is nothing but 2. With the 2, if the first die is nothing but only 2, with the 2, how many number of possible outcome for the second die? Nothing but 2, 1. Next 2, second die is nothing but 2, 2. Next 2, 3. 2, 4. 2, 5. 2, 6. Next, this first die is nothing but getting 3. And second, how many number of possible 6 outcomes? What are they? 3, 1. 3, 2. 3, 3. 3, 4. 3, 5. 3, 6, right? Next, same like that, 4, for 4 also. First day is nothing but 4, 4, 1, like this, right? Next, 5, 1. Next is, first day is nothing but 6, 6, 1, up to 6, 6, right? So first day, how many number of that we are having? 1, 2, 3, 4, 5, 6. Second day, what are the number of possible outcomes? 1, 2, 3, 4, 5, 6. Total number of possible outcomes is in the image, just you can count 1, 2, 3, 4, 5, 6, 6. And here also 1, 2, 3, 4, 5, 6, right? So 6 into 6, 36. So n of s for 2 dice is nothing but 36. It's a constant, it won't change. And what is the name of this one? Sample space for one die, sample space for 3 coins, sample space for 2 coins, and sample space for 1 coin, right? And this is nothing but sample space, and n of s is nothing but total number of possible outcomes, total number of possible outcomes. Understood? So first we have to write whatever they are asking. First, the question is nothing but based on 3 coins. right? First you have to write that what are the sample space, right? What are the possible outcome for the 3 kinds. First you have to write that, and depending upon the question, right? Depending upon the question, we have to write the favorable outcome and number of favorable outcome and total number of possible outcome. Like this we want to write and we have to solve, right? And this is also cards. This is also very, very important, right? Cards. So we have, so n of s for the cards is nothing but 52 only. So total number of cards is nothing but total number of cards in a pack is nothing but 52, right? So first 52 cards has been divided into 26 based on color. So totally 52 cards has been divided into 26 and 26. So 26 red cards and 26 black cards. So 52 has been divided into 2 based on color. First 26 is nothing but red. The next 26 is nothing but black. Then this 26 has been divided into 2 shapes. It's nothing but heart and diamond. Red heart and red diamond. In each suit 13 cards. Right? So in red totally 26 cards. The 26 card has been divided into 2 kinds. That is nothing but red heart 13 cards and red diamond 13 cards. And next 26, the black cards are divided into two shapes or 2 kinds. It's nothing but black spade and black club or clover, right? Spade, club or clover. So 13 cards. 26 card has been divided into 13. The first 13 is nothing but spade and the next 13 is nothing but club or clover. So in each 13 cards, it will be same thing only. It's nothing but each suit contains 1 ace, 1 king, 1 queen, 1 jack or knave, right? The name of jack is nothing but jack or knave, and 9 number cards, right? From 2 to 10. 9 number cards. Totally 13 cards. So 9 number cards, 1 ace, 1 king and 1 queen and 1 jack, right? Number of face cards in each suit. This is very, very important. Number of face cards in each suit is something but 3. It's something but king, queen and jack. As is not a face card. King, queen, jack alone, right? So in each suit, this is 1 suit, heart is nothing but 1 suit, diamond is each 1 suit, and spade is 1 suit, and club is 1 suit, right? Totally we are having 4 suits, right? The 52 card has been divided into 2 colors, 26, and each color it has been divided into 2 shapes. One is nothing but heart and diamond. In black we are having 2, that is spade and club. This is very important, mark, just note. Finally we are seeing one note, right? Something but at most, at least, equal to, either or, neither or. This is very important, right? At most, at least, these are very important, right? At most, right? First I am giving some sample space. 1, 0, 1, 2, 3, 4, 5, 6, 7. I'm writing that. This is nothing but sample space they have given, right? They ask you to find the probability at most 3, they are saying. At most 3. What is the meaning of at most 3? Less than or equal to 3. Less than or equal to 3. That is, maximum is 3 only. That means at most 3 means maximum 3 only and less than 3. So what are the favorable outcome for at most 3 is nothing but 3, 2, 1, 0. The maximum is 3 only. So 3, 2, 1, 0. Suppose 0 is not given here. 0 is not given here. So what are the favorable outcome for? At most 3 is nothing but 3, 2, 1. 3, 2, 1. Understood? So at most 3 means maximum number is 3, and below that number, what are the number we are having? All the number we have to take. At least means that from there only we have to start. At least 4 means minimum is 4 only. From 4 alone we have to start. So here for this favorable at least 4, what are the favorable outcome will come means 4, 5, 6, 7. Here up to 7 only there. So we are choosing 4, 5, 6, 7. So at least 4. Right? A very good example for at least and at most. In a class, if a person want to get a pass mark, what they will say? At least 35 mark we want to get. Right? At least 35 mark. then only we can pass. At least 35. That means minimum we want to get 35 marks. Minimum. Maximum up to 100 you can take one. That's not a problem. But for getting a pass mark, right? For getting a pass mark, what they will say? They will use the word at least. At least you want to get 35 to get a pass. At most means maximum, right? What is the maximum mark in your class? What is a that means maximum. Suppose if any person getting 99, that is the maximum at most, right? And 99 and 98, 97, 96 all will include it, but it won't go more than 99. At most 99 is something, but right, that is the difference. Equal to means exactly the particular number alone. Equal to 5 means exactly that 5 alone. That is equal to 5. And these two are very, very important, right? Either or, neither or. Either or means, right? Either or means both we want to include it. Either 3 multiples or 5 multiples. That means we have to include 3 multiples as well as 5 multiple. 3 multiple, or a very good example we will discuss with the cards. Either red or black. That means in red card how many cards are there? 26. That also we want to include. And black cards also how many? 26. Right? That also we want to include. So totally 52 cards. Right? So both we have to include. But neither nor. Right? Neither diamond, right? Nor black. We can take this one. So we have to remove the diamond card fully and we have to remove the black card fully. Remaining what is that? That is the favorable outcome. Understood? Neither nor is something, but both are excluded. What is mean by excluded? We want to leave that the particular cards or particular things, right? We have to omit the particular things, and what is the remaining thing we are having, that alone the favorable outcome when neither nor is coming. Either or means we have to take both of them. We have to include both of them, right? Understood? That's all. So today homework is nothing but you just recall all those things and thorough that the important points to remember, and cards, how many cards are there in each card, how many in each color, what are the names we are having. Just thorough all those things, right? And this note and all those things, you just thorough it, right? Tomorrow onwards we will start a class. Tomorrow onwards we will see the sums, right? Thank you.